All right. Before we find the probability of a type 2 error, there's one very important question, and that is how does alpha get determined? Alpha is the probability of making a type 1 error. And we've seen that that happens when you reject the null, when in reality you should not be rejecting. So that the short answer is that determining alpha, you basically base it off of the consequences. You base it on the severity of making a type 1 error. And I try to more or less talk about that initially. So here's what I mean by that. In this example, example 0, we saw that a type 1 error means that evidence indicates the car is not safe, but in reality, the car is safe. And we said that that happens when you're overly cautious. That's not a bad thing. This is pretty good. So type 1 error, making a type 1 error is not bad in this case. We're perfectly okay with that. However, check this out. A type 2 error is saying that evidence indicates the car is safe to drive, but in reality, the car is not safe to drive. So the consequences of a type 2 error are more severe than the consequences of a type 2 error. And this is why you want to learn to interpret them. So here, this is like somebody dies, right? So I don't know how to draw somebody died. So yeah, somebody dies right here. Severe consequence. Whoa, I don't know what that is. Severe consequence in making a type 2 error. So remember that's beta. Now alpha, this is overly cautious. This is not bad at all. And notice how beta is very high, alpha is very low in the sense of like beta. Alpha is not a bad thing. Type 1 error is not a bad thing, but type 2 error, very bad thing. Example 3, I'm not quite sure which one of those would be worse. It could be like false advertisement. But I'm not sure how, severe that is, unless you're the college, then it really matters. All right. And so what you want to notice is that the higher alpha is, so in other words, the more likely it is that you're going to make a type 1 error, the lower it is that you're going to make a type 2 error, and vice versa. And so you'll see in the next section why that is, but that's just something that's well known. So alpha and beta, they are said to be inverses. So you can minimize alpha, which would be a type 1 error, or you can minimize beta, which would be a type 2 error, but you cannot minimize both. So you really only want to go ahead and say, well, which one of these errors is worse, and then minimize that one. Remember that we control alpha. There's only a few choices for alpha. And so to help us determine why is, let's take a look at this guy. So let's start with the very last one. If you get a sample that has a p-value very small, less than 0.001, then there's very strong evidence against the null hypothesis. And what you're basically doing is you're saying alpha is very small. And if alpha is very small, then that means that you're looking for very, very convincing evidence for you to reject the null. Visually, you're saying that your critical region is very far away. So instead of being here, you're pushing it further and further out. So you're requiring very intense evidence, right? Very significant evidence to reject the null. So if you have that very significant evidence, then you're going to reject the null. This basically happens when you minimize type 1 error. So again, the idea is if making a type 1 error has severe consequences, make alpha very small. For us, we're going to go ahead and say very small could be 0.01. 0.001, that would be like airlines trying to ensure that their flights are safe, or medical devices trying to ensure that, a product won't kill anyone. So this would be more like safety. Whenever safety is a concern, and committing a type 1 error is very, very serious. You want to go ahead and let alpha be between 0.01 and 0.001. And what that means is that you're more likely to commit a type 2 error, but that's okay. You're basically going to say, I'm overly cautious in this case, right? Evidence indicates that my instrument or my technology is faulty, but in reality, it works perfectly fine. I'm just being overly cautious. I'm okay with making that type of error. I am not okay with saying this is perfectly safe to use when in reality, it could kill someone. And so again, there's more for safety. It could be that making a type 2 error is more severe. So if making a type 2 error is more severe, that means you're going to allow type 1 error to occur more often. So if a type 2 error, which remember is beta, is more severe, then that means you want to get beta to be as small as possible. So that means you're going to increase alpha. And so by increasing alpha, that would be over here. Okay, we're going to try and stay at a sweet spot of 0.05, which would be somewhere between that we're not really taking a stand against which of these errors is more severe, type 1 error or type 2 error. Let's go ahead and take a look at one example. This is essentially just interpreting the kinds of error possible. So this one says an EMT. So again, these are people who are on the ambulances and they're usually first to arrive. And they need to assess whether the patient is alive or dead. If the patient is alive, then they get transported and get further help. If the EMT determines that the patient is dead, then they essentially ignore that person and focus on the living victims or casualties. So you can tell that this is actually a pretty big deal, right? Is this person alive or is this person dead? So here are the hypotheses. The patient is alive. And then that means that the null would be that the patient is dead. Okay, so what does making a type 1 error mean in this context? So in this context, if you forget, just go ahead and take a look at your little table on the last 2 pages. So what is making a type 1 error? So again, type 1 error means you land in the tails. Type 1 is alpha. So that means you reject H0 when H0 is true. So let's interpret that. That means that the type 2 error happens when you fail to reject. And again, if that's an error, that means but H0 is false. All right, so in context, what does that mean? Reject H0, so the evidence, so this is the EMT, right? So that what I mean is that the evidence, they inspect the body, the individual, maybe look for a pulse, look for other activity. I have no idea, I'm not an EMT, but we're going to say that the evidence indicates or supports they reject H0. So if they're going to reject H0, they're going to reach this conclusion. Indicates that the patient is dead. However, we know that in reality, the patient is alive. All right, now let's interpret part B. What does making a type 2 error mean in context? You fail to reject the null, but the null is actually false. So my evidence indicates that the patient is by indicates, I mean that it supports this this hypothesis. So evidence indicates the patient is, we failed to reject the null, so we're sticking with the null, is alive. In reality, patient is dead. All right, so now that we've interpreted both of these errors, which one of these is more serious? After reading this, I hope you recognize that type 2 error you're basically saying a dead individual is alive, and therefore you're gonna like try and care for them, transport them to the hospital, and then worst case is they say, oh, they're dead now, so they're declared dead on arrival. So they were already dead. You think they're alive, so you try and save them. I don't see this as a bad thing. So is it bad? I don't know. Maybe if there were 20 other people that needed help, but you spend your time on this, maybe that could be bad, right? So again, this would depend on whether it's like a huge emergency. Then this would be a really bad error. You don't want that. But look at the first kind of error, type 2 error. You're marking someone as dead when in reality they're alive. So you could be killing this person. You are killing this person, right? If oh, they're already dead, I'm just going to leave them there. I'm going to ignore them. I'm going to go focus on someone else. So I would argue that this is actually a very bad error to make. So this would be like a severe mistake. So I'm not sure whether type 2 error is bad, but for sure type 1 error is pretty bad. You're supposed to save people, but you're killing them by believing they're dead. So because that's a severe mistake, that means you want to avoid making a type 1 error. And if you want to avoid making a type 1 error, you're going to make alpha as small as possible. So the conclusion, because type 1 error is severe, we're going to minimize alpha. Make alpha as small as possible. So if you take a look at our little chart here, you might say that, okay, alpha is 0.01, right? So that way you need strong evidence to reject the null. In other words, that would be strong evidence that this person is alive. So maybe that would be them like, their heart missing or something. You're like, okay, this person is dead. Again, the stronger you make the evidence, right? Like if there was a bomb and somebody exploded, you're like, yeah, this person's dead. That would be like 0.001. You don't want to make that. You don't want to make your evidence like unreasonably large, right? Like 0.0001. That's like very, very unlikely. That would be like, I can't find the body, right? You just have body parts and they're definitely dead in that case. That shouldn't be your go-to. And so that's why we have a bunch of different levels here of evidence. For safety, it might actually be that strong, 0.001, but not for something as, for example, EMT. Maybe they take the body temperature, check the pupil, right, whether they dilate, and then maybe check for a pulse. And if all of that is negative, then, okay, they can be safe. Again, is there still a possibility that they're going to mislabel somebody as dead when in reality they're alive? Yes, but you've minimized that because you have done a lot of checks now. Okay, so that's the idea. We're never actually going to be able to eliminate the risk of any of this kind of error, but this is more or less the way that this will work. So we'll go ahead and maybe do one more example on determining whether to minimize alpha or beta. But that is, in essence, how alpha gets selected. So if you ever wondered, we're just always doing alpha 0.05 because that is a nice halfway point between minimizing alpha or minimizing beta. All right, I'll see you in the next one.